Good afternoon. I will discuss today how to draw an element. We had started a little bit in class, and I'm going to continue discussing how to draw an element, the Rutherford Bohr element to be more precise. What you need is your periodic table, and we're going to start with an example of beryllium. Beryllium, over here. Pay attention that in the boxes you'll have two numbers that you need, the atomic number and the mass. So beryllium has an atomic number of 4 and it has a mass of 9. So we'll just round it up to 9. So what you do is you first write the symbol Be and you write the information, the atomic number 4 and the mass is, we said, 9. Okay? So once you have that information, write down pen, protons, how many protons, how many electrons, how many neutrons. So a reminder for protons is equal to electrons. So whatever proton you get, it's the same as the electron. How do you find that? Well, it's with the atomic number. Atomic number. And it's the same thing, atomic number. Neutrons are found by finding the mass minus the atomic number. Mass minus atomic number. Why? The nucleus in the middle of an atom is dense. It's dense in protons and neutrons. That's why the bulk of the mass is all in the middle of the atom, in the nucleus. So when you find the mass minus the amount of protons, which is atomic number, you will find the amount of neutrons. So let's find for beryllium. How many protons does beryllium have? 4. How many electrons? It's the same, 4. How many neutrons? 9 minus 4 is 5. Good. Now, remember we said that the protons and the neutrons are right in the middle of the atom. So if you draw a big circle and write down your information. Protons, I have 4, so 4p. And neutrons, I have 5. 5n. Okay, now where are we going to draw those electrons? I have 4 to place. So it says here that beryllium is on period number 2 and family number 2. So period number 2 means I need to draw 2 energy levels or shells. And it has 2 valence electrons. Valence electrons, reminder, it's the amount of electrons on the last shell. So 2. And we have 4 electrons in total to place. So I'm going to write the remainder in the front. 2. 2 plus 2 is 4. Got it? So here's just one small rule for electrons on every shell. You can only have on the first level for electrons, you can only have, hold on, first level, you can only have 2. It can only occupy 2. On the second level, you can only occupy 8, maximum of 8. And on the third level, you can occupy a maximum of 18. Okay? And in addition to that, valence electrons, no matter how many shells you have, is a maximum of 8. Very important information to write. Okay? Very important. So this is the number of electrons on each shell. Let's try fluorine now. Fluorine. Fluorine is atomic number 9, mass is 19. We'll round it up. So, again, fluorine, atomic number 9, mass is 19. You write pen, protons, electrons, neutrons. Protons, atomic number 9. Electrons, same thing, 9. Neutrons, 19 minus 9, 10. All right, now I'll draw my nucleus. My nucleus has 9 protons. It has 10 neutrons. How many shells do I draw? Fluorine is on period number 2. So I'm going to draw 2 shells. Fluorine is on family number 7. So it's going to have 7 valence electrons. 7 valence electrons. Remember that valence electrons are on the last energy level. I have a total of 9 electrons to place. So since I have 7 here, I have 2 left, and I'm going to write it here. In total, that's 2 plus 7, 9. 2 plus 7, 9. Now I want you to try it with various elements anywhere from 1 to 20. Have a nice afternoon.